Hello and welcome to NECTech Hub. Today we're discussing a question in strength of materials. Please like and subscribe to my channel. Okay, so today the question says that a portion of the shifter mechanism for a car with a manual transmission system is shown in figure below. That's the figure at the side. So a force of magnitude 8 Newton on the handle as shown is required to actuate the shift link BC. A two-force member. So A, neglecting any frictional effect that might be present, sketch the free body diagram for the shifter ABO. Take the joint at O to be a pin joint. It means that the joint over here is going to be in terms of X and Y. Then B says determine the magnitude of the force that acts on the shift link BC. And C says that calculate the stresses on the shift link if it has diameter 1.2. so this link on this shift link, if it has diameter 1.2 centimeters, and if the length of the shift link is 30 centimeters, then determine the new length of the shift link under this stress. Let's say if you take the modulus of elasticity to be equal to E is equal to 700 kilopascal. So basically, the first thing you need to draw is a free body diagram as it said in the E. So let's go and do that. So first of all, you draw the structure of the body, then you indicate the forces and then their directions with the distances from each point. So basically, move on to draw your structure. So this is how our structure will look like. Then we name our point ABO. When we are done, we put our forces there. So the 8 Newton resolves to 8 cos 5 and 8 sin 5 respectively in the X and Y. Then our P also resolves to P cos 15 and P sin 15. And because our O is a pin joint, we are going to get what? Two forces in terms of what? X and Y. Then we add our distances nicely. And that will be our free body diagram. Nice free body diagram, and then we are done. We move on to the next question that says that we should find the force in what? In the link BC, and that is what? P. So we are going to find that force. So first of all, use the free body diagram to do that. So the free body diagram is here. So if we take moment about O, we'll be able to find P. So taking moment about O, we are going to say that what? P sin 15. If we take it clockwise, P sin 15, which is here, we'll be multiplying with 25. So it's going what? Clockwise. So it's positive. P cos 15 is also going clockwise this way, as you can see, and it's 75 from O. And then 8 sin 5, which is here, is going anti-clockwise, is 25 from O. And then if you take 8 cos 15, it's 188 plus 75 from O. And that one is going clockwise, also plus equal to 0. You do your algebra very well. You make P the subject, and then P will be equal to negative 26.34 Newton, meaning that P is a compressive force. P is a compressive force. That's the meaning of that. There's not anything weird. So if we cut the forces, if we move on, so you find the stresses in each of the forces. So what they are saying is that if we cut B, if you take BC and then we cut B, the BC at D, then we are going to get a certain force compressing. That's 26.34. What is stress? Stress is just force over area. So force over area, we get that, we calculate nicely, we get our force over area. So our headache is to find the area, and luckily for us, they gave us the diameter. They said we should assume the diameter of the shaft to be 1.2 centimeters, which into meters, and then we get this to be our area. We get our force over area to be this. And if you still cut at C, so that's DC. If you cut it at C, you still get the same force, 26.34. You get the same thing to be your FDC, and then that will also be the same stress as negative 0.2 megapascal, and those are the stresses acting in C. Then we move on to the next one. The next one says that we should find a change in length. So that change in length, we know that change in length is basically what? Force times length over E times A. And we just put our data down. We know our force to be 26.34. We know our L to be 30 centimeters, which was given to us and then we know our elasticity to be what, 700 kilopascal, and then we know our area, so we just fix in our values, and then we get our change in length. But the question says that we should find a new length, and we know that if we are compressing, then it means that what, the old length will be greater than the new length. The old length will be greater than the new length. It means that change in length is equal to what, the old length minus the new length, which means that the new length will now become what, the old length minus what, the change in length, giving us 0.3 minus 0.1 to be 20 centimeters. And that is all for this question. Thank you very much.